Now we come towards the types of flow. That is, when liquid is flowing, it can be laminar flow, stable flow, or the turbulent flow. Now, first of all, it is study and turbulent flow. Normally, turbulent flow means if the Reynolds number is above 3000. In steady flow, the velocity of fluid particles reaching a particular point is the same at all times. That is called a steady flow. There is a flow is said to be steady if the velocity, pressure, and density at any point in the flow do not change with time, so that dV over dt is equal to 0. dP over dt must be 0. That is rate of change of momentum. That is d rho over dt. And d rho over dt will be 0, like shown in the tube. The flow is a steady flow. For a small velocity of fluid, concentrate on the motion of a particle crossing point A and B. In steady flow, all the particles crossing A with a definite velocity will cross the point B with another definite velocity. Velocity of particle may differ at A and B, but they will be same for all particles. So velocities will differ at A or B, but all the particles will move with same velocity. Now we come towards the turbulent flow. The speed of flow is larger. That is, rate of change of velocity will not be 0. That is, dV over dt is not equal to 0 at a particular point, and the flow becomes turbulent. Uniform and non-uniform flow. Like, for example, if the fluid is moving uniformly, it is covering equal volumes in equal intervals of time, and non-uniform, equal volumes in unequal time or unequal volumes in equal time. A flow is said to be uniform at any instant of time if velocity does not vary along the direction of flow. In non-uniform flow, velocity varies in the direction of flow. So it is shown in the figure, V2 is equal to V1. That is, at the 2 points, the velocities will be same. That is called the uniform flow. And now, in the next figure, V1 is the velocity at one position, V2 is the velocity at the another position. The velocity V2 is greater than V1 because there we find that the area is smaller or the volume is smaller, and at the left side the volume or the area is more. So V2 is greater than V1. So velocity at the right side point will be greater and velocity at the left point will be less. That is called non-uniform flow. Velocities are not the same. Line of flow, that is the streamline. The path taken by particle in flowing fluid is called its line of flow. So, line of flow is a path. The tangent at any point gives the direction of motion of the particle at that point. In a steady flow, all the particles passing through a given point follow the same path and hence a unique line of flow. This line or path is called streamline. So streamline means all particles, they are moving along the same line. Now the important point is that the path line or streamline do not intersect, they are parallel to each other at a particular time, as one particle cannot have two velocities at particular time. Now tube of flow, when many particles flow in group, that is called the tube of flow. So consider an area S in the fluid in steady flow and draw streamlines from all the points of the periphery of S. When we speak periphery, we are referring to curved surface. A tube such made is known as the tube of flow. Now it is shown in the figure. That is, we can say the periphery of S. That is, there a streamline flow is taking place. So such type of flow is called the tube of flow. irrotational flow. Irrotational flow means that there is no net angular velocity of the fluid particle. This makes the flow much simpler. If all molecules will start moving on the axis, then it will not be a simpler flow. So irrotational flow means all molecules are moving in a straight line, not angularly. If we take a stick and rotate inside a beaker containing water, then water particles start rotating. Similarly, vortex are formed in flowing river, which makes the motion very complicated. Now we come towards the equation of continuity. Here we have to take the velocities and areas. The continuity equation is mathematical expression of the law of conservation of mass. That is, mass is not created or destroyed. But here we are referring to fluid dynamics. That is, the fluid is moving and its mass will remain same. Consider two cross sections A1 and A2 containing the points A and B respectively. In a tube of flow, let speed of fluid be V1 and V2 respectively at A and B. As the fluid is incompressible, you will bear in mind that no fluid is incompressible. All fluids are compressible to some extent. So fluid is incompressible. The amount of fluid entering A1 in time delta T must be leaving A2 in the same time. Now A1 V1 delta T must be equal to A2 V2 delta T will cancel off. So the equation of continuity can be written as A1 V1 is equal to A2 V2. That is, product of areas and velocities on both sides will be equal. So this is what indicated in this figure. That is, at point A, the area is A1 surrounding A, and at B, area surrounding is A2. Velocity at A1 is V1 delta T, and at A2 or B, it is V2 delta T. Therefore, the product of area of cross section and the speed remains same at all the points of the tube of flow. And this is what known as the principle of continuity. Now we come towards the Bernoulli theorem or the Bernoulli equation. So we have not to drive much about it. We have simply to remember it for applying in the numerical problems. It is mathematical expression of the law of conservation of mechanical energy in the fluid dynamics. That is, energy is neither created nor destroyed. Every point in an ideal fluid flow is associated with three kinds of energy. Because the fluid is flowing, so obviously it must have kinetic energy. And in the Bernoulli's equation, we consider the tube of flow. The area is A1, pressure is P1. So force at point A will be P1 A1 and force at B will be P2 A2. Heights of the portions will be H1, H2. One is at the higher point, other at the lower point. Every point in an ideal fluid flow is associated with three kinds of energies. Kinetic energy. The kinetic energy per unit volume at a point in a flow is kinetic energy over volume. Now, kinetic energy is basically half mv square. So, half v square is written as it is. And per unit volume means 1 unit volume. So, we have only shifted mass, where mass is density into volume. Density into volume. And density is taken as rho and volume is v. Potential energy, that is equivalent to work done stored in the liquid. The potential energy per unit volume at a point with respect to an assumed datum. So potential energy by volume is equal to rho gh. Third one is the pressure energy. The pressure energy per unit volume at a point in the flowing liquid is defined as the pressure at that point that is pressure energy over volume, is equal to P. According to the conservation of energy flow, the sum total of these three energy remains constant. That is the conservation law. Along a streamline in a steady flow of an ideal liquid, therefore half rho v square plus rho g h plus P, that will be constant. Sum of three numbers will be constant. And this equation is called the Bernoulli's equation.